Hello everyone, my name is Viraj and today we'll be solving the fifth problem from the CP-31 sheet by TLE Eliminators under the 800 rated questions. Let's go. So I'll be moving on to my TLE-31 sheet over here. I have ticked off my 800 rated parameter and I'll click on my fifth problem, Jagged Swaps. Alright, let's read this. You are given a permutation A of size n. You can do the following operation, that is, select an index I from 2 to n minus 1 such that a of I minus 1 is less than ai and ai is greater than a of I plus 1, and then you can swap ai and ai plus 1. Alright, determine whether it is possible to sort the permutation after a finite number of operations. Alright, so they have used a lot of you can say beginner friendly terms such as permutation, and they have given you a complex complex sort of a representation also over here, that is the swapping. So what we'll do is we'll try to first generalize the problem and understand that what is actually asked of us so that we get a better grip of what is required. Okay, so over here I have taken an array. They are saying you have been given an array and this array is of n size, and they are calling this array a permutation, n size permutation. So we'll first understand what does a permutation mean. Okay, a permutation is simply an array. If let's say I talk about an n size permutation, then an n size permutation is basically an array which has all the numbers from 1 to n, and the numbers are, you can say numbers are unique. These are the main 2 points that happens when I talk about a permutation. So this is point number 1, you have the numbers from 1 to n, and this is point number 2, numbers are unique. What does this mean? Simply means that let's say I have n equals to, let's say 5. That means I will have all the numbers from 1 to 5 coming in this array. That's point number 1. And numbers are going to be unique, as in every number is going to come only once. So I can have them in any order, right? So basically, since these are the only 2 conditions, nowhere it's written that you have to, let's say, put 1 at the very first, so let's say 2 at the very first, that is one of the numbers from 1 to 5. That's not there. That means automatically it's understandable that any order works for me. So if let's say I have a array that looks like 3, 2, 4, 5, 1, then this is a permutation. Why? Because it has all the numbers from 1 to 5. You can see I have 1, 2, 3, 4 and 5. And these numbers are coming only once. I can see no repetition. 1 is not coming twice, 5 is not coming twice. Every number is coming only once. So this is of course a permutation. Let's say had I taken the permutation to look something like this. Let's say for n equals to 5 size permutation, something like 5, 2, 1, 4 and 3. Can you say this is a permutation of 5 size? Yes, it is still a permutation of 5 size because it is also following the 2 given conditions that were only required for it to be a permutation. That is, numbers from 1 to n are coming in this array and numbers are unique. So if these 2 conditions fulfill, that is something they have written over here also, a permutation is an array of n size distinct digits from 1 to n in arbitrary order. If these 2 conditions fulfill, then you will call the array to be a permutation. I hope this should be clear. Now let's begin the problem. They are saying they have given you an array A that is a permutation of size n. That means I'll take an example over here only, that I'll say, okay, this is an n size permutation, so I'll rub all this part and I'll say, all right, let run rub this. I'll write it over here that this is an n size permutation for n equals to 5. Now, once you have understood a permutation, they have told you that you can perform an operation. Okay, you can perform an operation. So I'll mark these as indexes. I'll say, okay, this is index 1. I'm doing a 1 based indexing, index 2, index 3, index 4, index 5. So the operation that they are saying is from indexes, you can say from index 2 to I minus 1. Sorry, not I minus 1. I'm so sorry over here. N minus 1. That is, in this case, you can write 2, 2 because n is 5, so you can write 4. So basically this index and this index. For these 2 to 4 indexes, you can pick up any one index such that, so I'll take this to the next page, such that, so pick any index from, you will say 2 to 4 in this case because n was 5. Such that let's say I pick the ith index, some random ith index, then I'll say that a of I, that is the ith index's element, is greater than the element that falls previous to it, that is a of I minus 1, and it is simultaneously greater than the number that falls after it, that is a of I plus 1. Such that this is the main condition. So if you select some ith element, considering that that I index is from 2 to 4, or basically in a generalized way it's 2 to n minus 1, then this index should satisfy the condition that the number kept at that index, that's a of I, should be greater than the number kept at the previous index and should be also greater than the number kept at the next index. If you are able to select such an index, then the operation says that you can swap a of I and a of I plus 1. That means if let's say this condition becomes true, then you can just swap these two positions, and now ai goes to ai plus 1, ai plus 1 comes to ai, or basically the number kept at ai goes to ai plus 1 and the number kept at the I plus 1th index comes back to I. So this is the whole operation that is allowed to you. This is something that you can do considering that you have selected an index which satisfies this condition. So I hope this part should be very, very clear. Alright, if you have any doubts, you can just pause the video and try to go back through the problem once again. Since the problem is very, very short in terms of statements, you will understand the problem very quickly. Alright, so now let's say you are trying to do this operation. You do it, so let's say sometimes. What is the main argument? What is the main question? Sorry, not argument. What is the main question that they are asking you? How many times do you want to do this and what are you trying to achieve? So the argument over here is, they have said, we are actually trying to sort this permutation and we are trying to sort it in some finite number of operations. So our target is by the power of the operation, sort the permutation. This is something that is given to you. Alright, now when I say that I have to sort the permutation, what does that exactly mean? Of course, if let's say I have an n size permutation, then eventually if I want to sort it, if I want to say it's fully sorted, then it means the array now looks like, let's say if it's n size, then it looks like 1, 2, 3, 4, 5, so on till last number n. This is going to be the array because it's sorted, so 1 comes first, then 2, then 3, then 4. Simple, you can say increasing order of 1 to n numbers. This makes sense. This is clear to me. So if I sort the permutation, it should look something like this. And this is my target. I want to somehow utilize the operations in some finite manner. It's no restriction, by the way, how many number of times do I do it. I just want to finally get the answer to whether I can do this or not. That is in terms of yes or no. If you can fully sort this permutation by the power of these given operations, you print a yes, else you print a no. This is the whole problem. Alright, I hope this should be clear. Now what we'll do is actually we'll move on to some sample test case, so that it becomes much more clear so as to how can I actually get the answer. So over here they have said that, okay, this particular solution to this particular problem is yes. Okay, this particular sample case is yes. So it's basically 1, 3, 2, and then you have 5 and 4. Now why is this coming out to be yes? Let's try to understand. Very simple. You want to achieve that something looks like 1, 2, 3, 4, 5. Simple. This is something you want to achieve. Now if you picture over here, let's say I talk about this element. This element, for this, the I is basically 4. So this is 1, 2, 3, 4 and 5. So I is basically 4. So I of course falls in the range from 2 to n minus 1. Basically that means 2 to 4. So I is 4. And this number is greater than the previous number and it's also greater than the next number. So can I swap these two locations? Yes, I can swap. So over here what happens is, I'll say, okay, from here I will swap these two locations. And the array now looks like 1, 3, 2, 4 and 5. Good to go. Now let's focus once more. Let's look at this question. I for this is 1 and this is greater than the previous position and greater than the next position also. So can you swap these two locations? Yes, I can. So I swap and this becomes 1, 2, 3, 4, 5. And let's say this was the target and this is what I finally got. Aren't these two same? Yes, these two are same. So will my answer be yes? Of course my answer becomes yes, because after finite, or to be very specific, after only 2 operations, I was able to fully sort the permutation that is given to me. Alright, so this is the whole idea, this is the whole problem. I hope you have understood with the sample case also and with general discussion also. Alright, now you can actually pause the video and maybe go through some test cases once more, sample cases, so that you get a better grasp of what is finally getting asked and how are you printing yes or no, maybe some logic of what happens in the problem and how do you figure out. Alright, But if yes, let's go ahead and discuss how do I begin thinking of the problem. So first of all, even without going into the discussion of where do I start with the problem, we should have an general idea of what time complexity do I want to achieve. This is very important because it helps me identify what are my redundant ideas which I don't want. All right. And how do I identify that part? Very basic. I have something by knowledge. I know that 1 second gives me basically 10 power 8 elementary operations to perform. This is something I know for sure. Now, in this problem, I have been told that time limit per test is 1 second. What does that mean? If I talk in 1 second, I have one test that can be followed, that is time limit per test. And in one test, that means you have 10 power 8 elementary operations. So each test allows you 10 power 8 elementary operations. But in each and every test, there are some test cases. You can see each and every test contains multiple test cases. And test cases are in order of 5,000. So if let's say I ask you what's the number of operations you can perform for each and every test case, then that kind of changes, right? This becomes something that looks like 10 power 8 upon 5,000. That's the highest number of test cases you can have for each and every test. And this becomes 1 by 5 into 10 power, this is 10 power 5. So if you write this very acutely, this becomes 0.2 into 10 power 5, or to be specific, this becomes 2 into 10 power 4. Alright, now this is very important. 2 into 10 power 4 elementary operations per test case is very important because if I look at n over here, which of course is good to assume that will be the main term that comes in my time complexity, n being in n being in 10 order only, I know I can create solutions up till n power 4. N power 4 means I will basically have 10 power 4 specific operations. 10 power 4 basically is 10 power 10. Keeping n as 10, you can get this as 10 power 4, and 10 power 4 is less than 2 into 10 power 4 operations. So O of n power 4 goes, but if I go above this, that is n power 5, will this go? Of course no, this is not going to work. That means this is sort of an upper bound over here, right? You cannot exceed some complexity of n power 4 sort of an order. Up till this, you are good to go. And since you are good to go in this order, of course, anything below this is good to go. N cube, n square, you will have O of n only, so on, so on, so on. If you even if you are able to create, let's say, a constant solution, you are good to go. So this tells me that I have a very large boundary, by the way, right? If I can create a solution that's in n power 4, I do have a very large limit of brutally solving this problem. Most problems do not have such a small constraint that you're able to go till n power 4. Although I'm not making a for short case over here that I would want to solve the problem in n power 4. But even if I go to a solution that's in n power 4, I'll be good to go. And this creates a solution in my head that, okay, n power 5 is redundant, but if I go till n power 4, great, good to go. Maybe I'm able to create something even below this, that's fine. But then I know for sure by an idea that n power 4 still gives me a AC, it will not fetch me a TLE, considering my logic would be right. So this is my expected time complexity, a very good discussion which is going to help me identify in even another problems also, it might help me identify redundant ideas. Alright, great, good to go. Now what we can do is we can start discussing our problem and our idea. Okay, so the problem in our case is basically a simple problem if you understand the argument. I have a very simple argument that solves this problem. Let's try to discuss this. My argument is if the first number in the initial array is 1, then answer is, you can say yes, else answer is no. This is my argument. Now you will ask, oh, this seems to be a very basic argument. All you are saying is that in my permutation, that's my initial array that's given to me, the first number needs to be 1. If the first number is 1, then the answer is always yes, else the answer is always no. So very simple argument, right? Very simple thing to write, even code and understand. But why is this argument true? Why am I quoting this thing? So we'll try to prove ourselves and see where am I getting this intuition and where am I getting this idea. So point number 1 over here is, if I observe very carefully, the power to swap numbers and like change the positions of some numbers is effectively not given in every range. Over here you have been told that the index needs to belong from 2 to n minus 1. Now which is that one index that doesn't fall in this range? Or to be very specific, which is that one index which has no power to change its number. If you carefully observe, if let's say you have the array, you have A1, let's say A2, A3, and let's say A4. Only this much. I'm not going to a very large number. Now, if let's say you have the power to pick up these two elements, that's basically index number 2 to index number n-1, this is 3. But considering that you can swap these two places or these two places and so on, you can see that the whole power of swapping is kind of limited in this area. That covers all the area after and from A2. So from A2 to A4, by some or the other method, if let's say the condition satisfies that the current element is greater than the previous and the next, you have the power to make some elements go from some location to some other location. That's right. But if I carefully observe, there is a very loner element over here. That's actually the first element. Do you think you can change the value of A1? First of all, the A1's value can only be changed if, let's say, you had the power to swap something between A1, or if A1 as an index 1 fall in the range of given possible ranges you were allowed to do this manipulation on. And the range is from 2 to n-1, so of course 1 doesn't fall in this. So my question is, do you even have the power to manipulate the value that was initially kept at A1? So initially whatever this value is, do you have the power to manipulate it? Question is power to manipulate this value. Manipulate this. And the answer to this question is, of course, no. I don't have this power, because it makes sense that the range of I in which I can perform operations are from 2 to n-1, and effectively it gives me the power to swap some numbers from A2 to A4, or basically A2 to last an number. But this A1 number never swaps. It never removes, it never changes the position, it never changes its value. So if it never changes its value, and the final target that is given to you is basically, target is to sort the array, then if let's say I sort the array, effectively the first number, what should it look like? Effectively the first number should look like 1. Is that right? Because you have the permutation that will look something like if let's say you have n size permutation, it will look like 1, 2, 3, 4, so on till n. So effectively the first number has to be 1. Now if you don't have the power to swap or change the position kept at the position first, that is the first index, then if the initial number is not 1, will you ever be able to manipulate that location? No. So if let's say in your initial permutation, let's say the number over here was 4, for example, and let's say if this was 4, then 1 was coming somewhere else. Let's say 1 was coming at this location. Ideally you would want 1 to come over here, because 1 has to be in the first location. But can you do that? This 4 will never move, right? This 4 will never move, because you don't have the power to make this 4 go from any location, go from its current location to any other location. That means if the initial number is not 1, the first number in the initial permutation is not 1, then you are in a big problem. You can always argue, I will never be able to sort the array, and my answer always becomes no. Alright, so this proves half part of our argument that I presented, that if the first element is not 1, then answer is no. Now I am saying that if the first element is 1, then irrespective of whatever initial permutation looks like, I will always get an answer yes. By that meaning, what I say is, if let's say the permutation look like this, initial number is 1, so you're good to go, but let's say the other parts are mishandled, it's basically like 4, 5, 2, 3, something like this. My argument is, you will be able to create an array that looks like 1, 2, 3, 4, 5. Why is this true? Let's try to understand this. If we go back to our argument, alright, that was, you can have the indexes, this power of swapping between the indexes from 2 to n-1. So if I look over here very cleverly, let's say this is something I want to achieve. So I'll just rub this off initially. And then right now, if let's say this doesn't have to move, then these are the places you want to manipulate. Now these places eventually want to look like 2, 3, 4 and 5. That means, let's go one by one. Let's cleverly observe over here that if let's say I talk about 5, then 5 essentially wants to move from the second position to the last position. This is the target. This is the 5's target, 5's whole scenario that 5 has to move to the last position. Now, why am I taking 5? You will ask. Because the reason is, 5 essentially right now in this range of numbers I just marked off, this range is the largest number. Now, if I take the largest number in a range, then for short, if you imagine, that number is always going to be greater than its left and right. because if it's largest, then of course it is greater than the left, and if it's largest, of course it's greater than the right element. So 5 in this consideration always is greater than its left and right, which is very clear, because if let's say in the left it's 4 and right it's 2, of course it's bigger. So in this case, what can happen is I can simply be like, okay, let me from this situation, what I'll do, I'll write this again, this was 4, 5, 2 and 3. What I'll do is, I'll select this index and I'll try to say, okay, this index satisfies the condition because 5 is greater than 4 and 5 is greater than 2. So fine, move 5 one place to the right, because it actually wanted to move more to right. So it wanted to move 2 times to the right, actually 1 and 2, but right now I can move it only once in one operation. All right, fine, let's do that. It becomes 4, 2, 5 and 3. Now I'll go back to 5 and I'll say, okay, 5, you're still the largest element. You essentially want to move at this location, and being largest, you are greater than your left and right. Okay, great. Let's go ahead and move 5 next to over here and swap basically. So like 3 and 5 get swapped. You get 4, 2, 3 and 5. Now what has happened essentially, you can see that in the current range right now, that was of these 4 elements, 5 was some number that was not located as its right location, but after 2 operations that you performed, 5 has placed back to its right location. Now do you think you want to move 5 from anywhere? 5 is at its correct location. I don't need to move 5. That means after this set of operations, my new goal can be to focus on this range, that is 4 to 3, and try to somehow make this range again sorted, that is same argument. Let's take the maximum in this range, that is 4. Arguably 4 being the maximum in this range will automatically be greater than its left and right. So move 4 once, so this becomes 2, 4, 3 and 5. Then again move 4 once, so this becomes 2, 3, 4 and 5. And essentially this ends your operations to give you an array that looks like 1, 2, 3, 4 and 5. And you have somehow, of course, in some finite operations, received what you wanted to finally achieve. So the argument over here is actually, if you fixate your 1 at the first location, by taking ranges in this order, that is, first you take the most largest range, 4 elements, then you shorten your range, 3 elements, then let's say if possible 2 elements, and so on, so on, so on. You can always fixate an ideology or a methodology where you pick up the largest element and try to move it to its desired location by shifting it more to the right. And this will always work because the largest element will ever be greater than its left and right. That's why it will always have the power to move. And because the largest element will always have the power to move, you will have in that current situation the capability to keep that largest element from its current to its desired location. So if this was the, let's say 5's current location, you were able to move it to its desired location. Next time, let's say 4 was at this current location, you were able to move it to its desired location, and so on, so on, so on. This can be kept on doing till you finally feel you're good to go, and you will definitely receive an array that is sorted. Alright, so this is a very clever idea. This is, of course, by intuition. When you draw on pen and paper, you get a hang of the test cases. You will clearly see that this is what I can follow. Now remember, in the problem, because it was never asked, report the operations or report the count of operations, you are good to go. Because let's say you do even 1,000 such operations, eventually all that is asked to you, are you able to finally sort the array or not? And because your answer is yes, since you knew that the first element was 1, and I was always able to do that by following this max element from a desired to current location sort of a methodology, then I know answer can be reported yes, because this works out. It will definitely, in some x finite operations, give me the right answer or give me the sorted permutation. Alright, so this is the whole idea, and this proves us our argument part. Alright, this argument part. Now once this is clear, let's move on to our code part. And if you get the argument, code part is, trust me, very, very easy, since all you need to do is check. Very simple thing. We'll take the input of t, we'll take the input of n, I'll take the input of the array. So up till here, all that I'm doing is taking input of the array. And then what I'll simply do is whether the first element, that is the initial element in my given permutation, 1 or not. If it's 1, then it's simple case, print a yes, else print a. Alright, so very easy problem. Now what's the time complexity? This runs in n order, and this is basically constant time complexity to check the looping. So you can say overall time complexity becomes O of n, which is basically O of 10 only, since you know n is basically given in 10 order. Now O of n is a very good time complexity because we knew we could have gone till n power 4 also, but we received a solution that's in n power directly O of n power, which is great and good to go. Alright. And if let's say I talk about space complexity, it's also dependent on O of n only, that's the size of the array. So this becomes O of 10 again in max situation. All of this is good to go, gets me an accepted solution, doesn't get me an TLE, and will definitely get you right solution even on these test cases. That is the sample, and if you submit this to the main problem, then you will also get an accepted solution over there. Alright, so you can see this is passing everything. Alright, so the whole idea of the problem was actually to observe, right? Again, the problem might be very easy once you code this up, but if I'm able to not understand why is this happening, then this might become a tougher problem. So I would recommend you pause the video, understand it a bit more clearly with more test cases with your pen and paper, and you will definitely get the picturization of why one at the first place gives you an answer of yes, and why if one is not at the first place always fetches you a no. Okay, so I hope you like the video. Thank you for watching.